Okay, now we start chapter 11. The first section we're going to look at is something that might be familiar. You might have seen it in your pre-calc class, but regardless, we're going to be looking at what's called continuous compounding. It uses the constant E. In the formula, you have A, which is your future amount, is equal to principal. Principal is the dollar amount that's borrowed or invested, times E, which is a constant, raised to the RT. R is interest rate, which must be in decimal form, and T is time. So in this, the base, I keep talking about E. It's 2.7182818. Keeps on going. It's a base amount of growth shared by all continually growing processes. If it's continuously growing, then this is the base for that particular growth. It lets you take a simple growth rate, find the impact of compound, continuous growth, where every nanosecond or faster you're growing just a little bit. E shows up whenever systems grow exponentially and continuously. Normally, when you are talking about population, decay, or radioactivity, interest calculations, and more. Some of the problems you're going to be facing with is actually using the formula. Some are being able to solve an equation, which goes back to your Math 1130 or 1730. Now it says use the continuous compound interest formula to determine the final amount. They give me the principal, the interest rate, and the time. You have to have these words compounded continuously in order to apply that formula. So first thing normally that I do is I substitute in. So my A is equal to 2,000 times E raised to, notice that has been changed to decimal form, times 8. Now let me get my calculator. Your E, the best one to use since I'm raising E up to an exponent, is this one right over Ln. If you do second Ln, you get the E, the caret, and a parentheses. So 0.0157 times 8 in parentheses. So if I have this money at this interest rate compounded continuously for 8 years, I would earn $267.66 in interest. Let's see if that's what I've got here. There it is. So this is how much that 2,000 can grow with respect to that rate for that amount of time. The next one, you've got 3,150 at 2.5% compounded continuously for 14 years. I need you to pause me. You go ahead and try it because I'm going to go ahead and do it. I came up with $4,470.06. Let's see, 4470.06 minus 3150. That's the amount of interest that amount of money would earn if it was at that interest rate for that time. So let's see if that's what I came up with. 447076. There it is. All right. I'll clear that off. In the next problem, now I'll have to move that down. In these problems, 3 and 4, they want us to solve x to 3 decimal places. Now this is something that you did do in your pre-calc class. If you remember, if you have a base raised to an unknown power, the only way that we can free it out is if we take log of both sides. Since E is my base here, then it is to my advantage if I use Ln. That's my natural log. So let me move this down a little bit. I'm going to take natural log of both sides. Remember, we have a rule. If I have a natural or if I have a log of something and it's raised to an exponent, do you remember your power rule? You can bring the power rule out front. Move on down. Now, something's going on here, if you'll notice. I had to get the green dot out of my way. Remember, natural log of e is equal to 1. So when we bring that out, we've got 0.25x times 1, which makes it very nice. Last thing I have to do is divide both sides by 0.25, which by here I did by hand, but then if I put it in my calculator, let's see, I do not know why I moved it, but I did. Natural log of 3 divided by 0.25. Now I rounded it. If I store this value, remember this is an equation and I can always see if it works. So second ln 0.25x, since I stored that whole value, it should come right up on the nose. There it is. Now, in order to do these problems, you have to understand they have to be a certain format, if you remember. You have to have the base raised to unknown power isolated. So this one is. So let's take ln of both sides again. Bring the 10x out front using the power rule. Only thing now I need to do is divide both sides by 10. And then I can get an approximation by using my calculator. So natural log of 2 divided by 10. If you had this in 1130, it depends on who you had, when you had it, but it was in Chapter 5 when you worked with logarithmic equations. Let's see, problem 5. Provident Bank offers a 3-year CD that earns 3.64% compounded continuously. $10,000 is invested. How much will it be worth in 3 years? Remember that A is the future amount, so that's what they're asking me to find here. So I'm going to have A is equal to my principal times E raised to 0.0364 times time. And if you do that in your calculator, you should come up with that. And pretty much, that's what they wanted for that problem. Now, here's a different question. Excuse me. How long will it take for the account to be worth $12,500? Now remember, my formula is A equals P times E raised to the RT. Whenever they use the word how long, that means they want to know about time. So the 12.5 is my future amount. The money invested is still the same. Interest rate still the same. So my T would be my time. Because I don't know, and that's what they're asking me for. So this is sort of similar to problem 3 and 4. You have to have base raised to unknown power isolated. So the first thing I did right here is divide both sides by 10,000. And then, if you'll notice, this step right here takes on the same look as 3 and 4 above. I'm going to take natural log of both sides, free out the exponent, divide both sides by that 0.0364. So if they want to find out how long it's going to take $10,000 at this interest rate to get to $12,005, it's going to be about 6.13 years. I'd say some people would like to know that, how long it's going to take them to do something. C part, how long will it take the original investment to double? Well, the original investment was $10,000. If I'm talking about doubling, that's 20. So let's see if we put the values in the appropriate location. So I want it doubled. There's the original investment, interest rate same, because they asked me how long is this going to take. Got to get my base, the E raised to whatever, isolated. Got to go free it out now. Let's take natural log of both sides to free out that 0.0364t. Last thing I've got to do is divide both sides by 0.0364. So see if you can come up with 19.04 years. So this is sort of a review of material that we had back in pre-calc, and some of this, comes into play in this particular chapter. So try the problems and see how they go. I'll talk to you later. Bye-bye.